Okay, today we're going to talk about functions. Now, we've talked about them before in 6th and 7th grade, but we're just going to go a little bit further with it today, determining if things are actually functions or not functions. So put functions at the top of your page and put today's date in the top right corner. Now, this is the analogy that you always get with functions, and you'll probably hear this 10 more times throughout your career as a math student. Pretend that functions are a machine. And allow me to draw a poor-looking machine. All right. So in this machine, in this function, you could call it, let's say the function is y equals 2x. Now, what you're going to do with that is you are going to funnel or input things in for x. So what you can do is put in, and I want you to actually draw this because it's a good analogy. You're going to put in numbers for x. So you're going to put in something like x equals 3. And then when you put in x equals 3 into this, so you would put x equals 3 into this function, 3 times 2 is 6. So you would actually come out with, pretend this is like a little output thing, you would actually get y equals 6. So you put things in and you get things out. That's what a function is. And in this instance, in most instances, you're putting things into as x and getting them out as y. And this is your, and you should label this is your input. It's always going to be x. And this is your output, which is always going to be y. Okay, so you should have drawn that. Now, for some definitions. A function is an input-output relationship, the x's and y's, that has exactly one output for each input. That part's important, and we'll talk about it in a second. Exactly one output for each input. That is huge. Now, the domain is the set of all possible input values. So these are your x's. So a domain could be, like if I were to do an example, it could be like x equals 0, 1, and 2. That could be your domain. That's what you're putting into the function. Your range is the set of all possible output values. For example, you put an x in and you get out like y equals 10, 12, and 14, whatever it is. So that is your outputs. So domain, inputs, range, outputs. All right. So how do we tell if something is a function or is not a function? Well, it says here that it has to have exactly one output for each input. Now, that means that, looking back at this illustration, you're putting one thing in for x, you're getting one thing out for y. What it doesn't mean is like getting, let's say we have this same machine, right, or a similar machine, terrible looking, and you put one thing in the top, and you actually get two things out the side, meaning you would put like a 1 in the top and get like a 2 and a 5 out. That means it is not a function. For every one input, there has to be one output. So here it says, make a table and a graph of y equals 2x plus 1. This right here is your function, okay? Y equals 2x plus 1. Now, you should be writing this down. I'm going to make a table like this, and you guys have done this quite a bit. I'm going to do 5 input values. So I'm going to do y equals 2x plus 1. Here are my y's. I'm actually going to do 5. Now, again, I'm going to pick easy numbers because it's just going to be easier on me and they're easier to graph. I'm not going to pick anything with a half or with a decimal or anything like that. I'm going to pick some negative numbers too so I get good representation. So I'm actually going to do -2, -1, 0, 1, and 2. So what I'm going to do is take this -2 and plug it in for that x. I mean, you guys have done this before. So you'd get y equals 2 times -2 plus 1. So that'd be -4 plus 1, which is -3. And then same thing for each one, right? So this would be -2 plus 1, which is -1. Y equals 2 times 0 plus 1, which is just 1. Y equals 2 times 1, which is 2, plus 1, which is 3. And then y equals 2 times 2, which is 4, plus 1, which is 5. Okay. So now I have my x's and my y's. I'm actually going to make another column here, x comma y. And I'm going to grab the x here and the y here. So that's going to be -2, -3, -1, -1, 0, 1, 1, 3, and then 2, 5. Okay. So I have to graph these, right? Let me make this maybe a little smaller. And let's make our graph. Try to make this as neat as possible if you don't have graph paper. I know it's kind of tough, but so there's your x, there's your y. Remember, these have arrows on them, right? Label that x and label that y. Now, my lowest number is -2 on the x, and my highest is 5. So I'm going to go up to 5. So 1, 2, 3, 4, 5. Let's go up to 6. 1, 2. Try to space them as evenly as possible. Okay. So -2, -3 right there. There's my first point. -1, -1. There's my second point. 0, 1. There's my third point. 1, 3. There's my fourth point. And 2, 5. There is my fifth point. And look at this nice line. And if you remember from last year, this is linear because it's in a straight line, right? So that's what you should get. And this is a function because for every, look over here, for every one input, these, remember, x's are your inputs, you have exactly one output, and they're all different. So you're putting in -2, getting -3, putting in -1, getting -1, putting in 0, getting 1. So for each one input, you have one output, not multiple outputs. So that's important. Okay. And remember, this, just to put it in context, this is your domain, right? Your x's are your domain, and the y's, the outputs, are your range. Okay, and we'll go over all this in class. All right, determine if each relationship is a function. Well, we have to have a it's called a one-to-one relationship, meaning for every one input, you have to have one output, one-to-one relationship. So for every one input over here, do we have one output? For 0, we have 5. Good. For 1, we have 4. For 2, we have 3. For 3, we have 2. So yeah, for every one input, you have exactly one output. Let me give you an example of when that wouldn't work. Let's say here for x, remember, for every one input, you have to have exactly one output. So let's say for this one input here, we have 5. And for this one input here, we have 6. For this input, we have 7. And for 2, again, we have 9. So for every one input, you have to have exactly one output. But if we use 2 as an input and we get 2 different outputs, this is not a function. For every one input, you have to have one output. So how do you look at that on a graph? Well, here, we do what's called the vertical line test. So let me get rid of this here. We're going to do the vertical line test. Now, the vertical line test, so just write that down, vertical line test. That's important. If you draw a vertical line and you hit more than one part of the line, it is not a function. So if I do a vertical line, or should be a vertical line, if I do a vertical line and I touch 2 different parts of the line, it is not a function. I hit it right here and right here. So that is not a function. What happens when we have something like this, y equals x squared? Well, let me make a table and a graph for that, and I'll show you. We have x y equals x squared. Remember, x's are our inputs, y's are our outputs. Okay. I'm going to do 5 points. I know it may seem like a lot, but you should be doing this as well. When you do more points, the more accurate, the nicer your graph is. So we're going to pick easy numbers. Pick negatives and positives, because that'll just give us a nice indication of the graph. So here, let's do -2. I'll just use the same ones, -2, -1, 0, 1, and 2. This is very common to use, okay? So that would be y equals -2 squared. Remember, -2 times -2 is +4, so that gives us -2, +4. Let's do this one, -1 squared. -1 times -1 is +1, so that'll give us -1, 1. 0 squared is just 0, right? 0 times 0. So that'd be 0, 0. And then y equals 1 squared. 1 times 1 is 1, so 1, 1. And then y equals 2 squared, which is 4, so 2, 4. So we have our points here. So let's go ahead and graph that. Now I don't need a ton of lines. I need to go up to 4. So I'll go up to 4. Forgot to put an arrow there. All right. So -2, 4. -1, 1. 0, 0. 1, 1. And 2, 4. And when you see this, it's actually called a parabola. It does not have a sharp line to it. It just goes like this. It's kind of like a U. Okay? And let's go back up to that vertical line test. If I can draw vertical lines and it doesn't touch more than one part on the graph, it's a function. So let me actually make a vertical line here. Yeah, we'll make that some pretty color. Like, let's say pink. Okay. Or not. Let's make it red. So if I can move this and it doesn't touch more than one part on the graph, it's a function. And notice, it doesn't touch more than one part of the line on a vertical line. So that is a function. So remember, one input has exactly one output. All right, that's it. Hope you enjoyed functions.